All right. So before we kind of get going into things, after class Tuesday, I put up an announcement on Canvas. So I mentioned this, but we're going to be split for the final exam between two rooms. So 1055 and 1059 in Hodge Hall. Those rooms are like right next to each other. Should be pretty easy to find, especially if most of you are familiar with kind of Hodge Hall. Just on that first floor, like almost like right when you walk up kind of that small set of stairs. They're right there. You might have even taken other exams, things like that in there. So if your last name starts with A through J, I'm going to have you kind of go to room 1055. It starts with what? K through Z, 1059. So that kind of gets us split up evenly given the room capacities of those two rooms. So they'll be pretty full. I think the capacity is a little bit larger, so it's like 180 and half the class is about 150. So do your best as much as possible to kind of sit towards the front, right? That just makes it easier to get the exams handed out quickly so that you have as much time as possible, okay? So next Tuesday, right, December 16th, from 5:20 to 7:20 p.m. is our final exam in these two room locations. I will not be starting out in those rooms with you guys, okay? So I'll be stopping by there, getting the exams to the proctors. I've already given them instructions. I'll reiterate them. It'll work just like the midterms, right at 5:20. Kind of they'll make an announcement. Everything should be put away except for something to write with and a non-graphing calculator. If you have anything else out, what are they going to assume you're doing? So do not have anything else out. Because if I'm not in the room, they're probably going to want to make sure that I'm really happy and they're probably going to be a little more stringent, okay? So if you're kind of bringing a pen, please bring a black pen. It makes it a lot easier to kind of make sure those get getting scanned correctly and they don't have to go through and do anything by hand, right? So a pencil or kind of a dark pen is preferred. Once that exam gets started, right, I'll be on the second floor of Hodge Hall with my other section to kind of get that started. Once I help them get the exams handed out, I will come back by both of those rooms and check to make sure everything is kind of started okay. I'll be bouncing between those three rooms the entire time. Just like the midterm, once the exams are handed out, if you want some extra paper to write on, they'll have a bunch of blank paper. Raise your hand, they can kind of give you some extra scratch paper to work on. But that's the only thing that should be out during the entire exam, okay? I'll be between the three rooms, so if you have a question at any time, you can raise your hand and ask the proctors. So there should be three in each room. If they're not sure how to answer it or they want to wait for me just to make sure they're answering it correctly, once again, I'll probably be in there every 15 minutes or so, right, for about 15 minutes and kind of bounce between those three rooms. So if they're not sure how to answer it, you can kind of move on to the next question and wait till I'm back in the room and able to answer your question, okay? So 2 hours, 30 questions on that exam. So what, 5 more questions in the midterms, but you've got 45 more minutes, so more time per question, right? So timing probably won't be as much of an issue here on the final as it was for the midterm exams, okay? Which is why it's weighted a little bit heavier and it has a few more questions, right? Other than that, I also put up an announcement about the extra CL sessions that are available tonight, right? So this is another opportunity for extra credit. So even if you've already attended the one Monday, it's almost like we're resetting, right? The CL sessions reset every Thursday. So this is like an additional week of possible extra credit. So I've got the kind of times and locations at every time. There's 2 available locations. After those pass, they will get the attendance file updated. I've kind of instructed them to make sure they do it after the session. So it should be updated tonight, and I will try to get those CL points updated on Canvas tomorrow, late morning, early afternoon, okay? So going into that final, you should have an idea of exactly kind of where you stand in every category, with the exception of what is also due by the end of the night if you haven't done it, that final Canvas discussion, right? So I don't want to see anybody miss these. These should be pretty easy points. If you have not done that 5th final Canvas discussion, make sure you're doing it by the end of the day tomorrow in order for it to be accepted as on time, okay? Those grades will all be updated by Monday, so you'll know kind of what your grade is in every category, plus your CL points by Monday going into that final exam. I've talked about you can use that Excel file with that hypothetical grade tool to kind of start plugging in those values and figure out what I need on the final to get certain grades in the class, okay? Grades should be posted pretty quickly after the final. I won't promise they'll be up on Wednesday. I will likely have the exam scores posted on Wednesday. Final grades might not be posted until Thursday after the exam. Okay. Other than that, I think that kind of takes care of the housekeeping stuff. Other than I mentioned I might not have office hours Monday. I'm not going to. I'm not able to kind of be in my office. Check for an announcement. I will likely be available virtually Monday afternoon. So I'll kind of have that virtual office hours link that you can use. I'm not 100% sure on that yet. I'm trying to carve out some time in the afternoon if you have some last minute questions, but I won't be in my office on Monday. Okay. Any other questions just logistically for me before we dive into kind of doing review here today? We're okay? All right. So does anybody have any questions that they want to kind of start out with here? Practice finals, module quizzes, practice problems. The first practice exam that was posted? Okay. So you said number 10? This one? All right. So if I give you a demand equation and I give you a constant marginal cost, right? I think it's asking you for what the profit maximizing quantity is, but I could also ask you for the profit maximizing price as well, right? So we've got a monopolist here, and we could do this for either a monopolist, single price monopolist, we could do this for a perfectly price discriminating, or we could do this for a perfectly competitive market. So we'll think about all three types, right? So I've got my demand curve, looks something like this. My marginal cost was told to me to be constant at 40. So if I wanted to give myself a visualization of this, I'm thinking about I've got this constant marginal cost at 40. My demand curve at a quantity of 0 would start at 100, and then it would be kind of decreasing. Okay. Now, if this was a perfectly competitive market, where would the optimal quantity be? So if we're a perfectly competitive firm, we always end up where? Supply is equal to demand. So if we're thinking about kind of our perfectly competitive market, what is supply? Every time you go back throughout the semester, what do I write next to the supply curve? Marginal cost. What do we write next to the demand curve? Marginal benefits. So I'm really looking for here, the quantity of a perfectly competitive market would be where marginal cost hits my demand curve. So if I'm looking for where that demand curve, which I have an equation for, is equal to my, well, supply as marginal cost, and it's just constant at 40, it's really just a little bit of algebra, right? Solving for where that quantity would be. So I think if I do that, I get what? 60 over 2, or that quantity would be 30. Okay. Now, this is almost a little bit easier than if I was looking at a monopolist. What is the price that the perfectly competitive firm would set? Yeah, in our long run, what's true about the price that's set for a perfectly competitive firm? We said everything is equal. Price is equal to marginal cost, is equal to marginal revenue, is equal to average total cost, etc. So we would stop. We don't really have a lot of additional work to do here. We know that that perfectly competitive market would choose or would result in that price of 40. Okay. Now, if I had a price discriminating monopolist, this is not what the problem says. I'm adding some things in maybe because they're worthwhile, right? If they can price discriminate, what is their marginal revenue curve? So usually with a monopolist, we think about their marginal revenue curve is twice as steep as demand, but that's only if they're setting a single price. So what is the price discriminating, perfectly price discriminating monopolist? What does their marginal revenue curve become? Yeah, they're setting the price exactly equal to the consumer's marginal benefit. So the price they set varies. This is their marginal revenue curve. So what quantity would the perfectly price discriminating monopolist choose? The same quantity as a perfectly competitive market, right? We end up at that quantity that a perfectly competitive market would end up. So what's happening? What's true about total surplus with a price discriminating monopolist? It is at its maximum, highest point. So what is deadweight loss? Yeah, deadweight loss for these price discriminating monopolists is 0, right? So we end up, if they can price discriminate perfectly, we end up at this point where total surplus is maximized, right? And the quantity would be 30. Now, what if instead I had kind of my single price monopolist, right? So if I have a single price monopolist, they face this twice as steep marginal revenue curve. So what would the single price monopolist's marginal revenue curve become? If I was doing this, I'd write it right below the demand curve, because marginal revenue should start at the same point as demand, but be twice as steep. I'm going to give you nice, easy numbers. 2 times 2 is 4. 3 times 2, 6. 5 times 2, 10. We're not going to give you these nice integer values, so we're not doing any kind of crazy decimals here, right? So what are they going to do? How do they set? Every firm sets the profit maximizing price where what? Marginal cost is equal to marginal revenue, right? So marginal cost is equal to marginal revenue where? Well, if I have my marginal revenue equation, I have this constant marginal cost. So in these types of examples, I won't make it any tricky. Usually we'd have an upward sloping supply curve. We'd have just a little bit more algebra to do there. But with a constant marginal cost, we simply have one value. So what would the kind of quantity be if I just do a little bit of algebra here? I think I end up with a quantity of 15, which let's say I did this and I somehow end up with a quantity of 45. Why do I know that's wrong? What should a single price monopolist be doing relative to a perfectly competitive market? Restricting quantity. I know that if I had the perfectly competitive quantity, if I've done both of these correctly, this quantity should be lower. So I know I made a mistake. 15 is lower than 30, so at least that looks like I did it right. At least in my head, if I did the algebra wrong, let me know, but I believe I did the algebra right in my head, right? So how would I then find that profit maximizing price? They take that quantity and they plug it into what? Well, how do we find the price? I go up to the demand curve. What was my demand curve? 100 minus 2Q. So I'd plug that quantity back into my demand curve, and I get what? A price of 70. So the single price monopolist, does it at least look like I've done some correct math here? Well, if the price of a perfectly competitive market is 40, the price of a single price monopolist should be higher than that. Okay, at least I didn't make any egregious errors, right? And if I'm thinking about a multiple choice exam, I can start to cross things out. If I've already had what the perfectly competitive market was, I know that that price has to be above 40, right? If I have a constant marginal cost, the price the monopolist, the single price monopolist set, will always be above or below that marginal cost. If I find the quantity where marginal cost is equal to marginal revenue, what's the second step to set the price? I go up, so price has to be above marginal cost. If you have a constant marginal cost and you have a single price monopolist, you know the price has to be greater than that marginal cost. So if we're thinking about kind of answers here, now I gave you kind of an assumed true quantity here instead of 15, 10, just so you wouldn't make cascading errors. But let's just assume that I didn't. Well, I know that it has to be above that marginal cost of 40. I could cross B out right away. But I know that can't be the case, right? Because we go up to the demand curve to set the price, we know that price the single price monopolist sets will always be higher, okay? So what is that difference? Just to kind of add some concepts in here. What is the difference between the price, and we typically didn't talk about this with monopolists, but what's the difference between price and marginal cost? My markup, right? So with a single price monopolist, I actually have a markup. Price is above marginal cost. What is the markup for a perfectly competitive market? 0, right? Price should be equal to marginal cost if it's perfectly competitive, okay? Does that answer your question on that one? Any other questions? Yeah. So here we need to maybe think about differences that we have in the short and the long run. So I gave you a depiction. I didn't tell you whether or not it was in the short or the long run. What are we in? If that model is correct, am I in the short or the long run? Why do I know I'm in the short run? because in the short run, I have fixed costs, so there will be a difference between my total and my variable costs. If there's a difference between my average total and average variable, I know I'm in the short run. Now, question 8, and this is probably on the exam, the format, I might be a little bit friendlier if it'll let me select this. I might do something like this, use a little bit more bolding probably on that exam, just to kind of identify this might be an important thing to make sure you're reading, right? If I'm in the long run, what happens to that depiction above? What kind of goes away? Variable cost. It doesn't go away, but it becomes the same as my average total cost curve. So in the long run, if I'm thinking about a perfectly competitive market, what point do we end up on? We said firms will enter and exit until the price is equal to average total cost because profits are 0. So if I'm thinking about a long run depiction of a perfectly competitive market, in fact, let me actually add this in because this might be something helpful for other questions that you might come across or you might see on the final. So let's say here's my average total cost. In the long run, it's the same as my average variable cost. Here's my marginal cost curve. Always hits the average total at its lowest possible point, right? So let's assume we had this in here. If this was the initial equilibrium price for a perfectly competitive market, that is their marginal revenue. Where does that come from? That comes from in the market, there is some supply and demand curve that the market faces that results in this equilibrium quantity. And it would result in this market quantity. This is the firm's decision that they face, right? So where will they set the profit maximizing quantity? Where marginal cost is equal to marginal revenue, right? So the quantity of the firm starts out right here. If this was the case, price is below what? Average total. So I know initially my profits are negative, right? If this is the long run, I've eliminated all fixed costs. If this is my average variable cost curve, if price is below average variable cost, what are firms going to start choosing to do? Shut down or exit the market in the long run. As they exit the market, what happens to the market supply curve? Decreases. Fewer producers, supply decreases, right? So that's going to occur. This is where I should probably bring rulers and things to class, but that just takes more time. So what's going to happen? Because profits are negative, firms will start exiting. What happens to the price in the market? It goes up. Now, here's a kind of counterintuitive result, and here's where we would, if we had additional questions, read them carefully. What happens to the quantity in the market here? It goes down. But notice, price is the firm's marginal revenue. So for the firms that remain, their marginal revenue curve, it's not downward sloping because this is a perfectly competitive market. We don't have any market power. So where does marginal revenue hit marginal cost now? At a higher quantity. So each existing firm produces more, but we have fewer firms. So the overall market quantity is going to decrease. So this kind of seems counterintuitive, but the idea there being, I've got the same demand curve, there's fewer firms, we kind of have a larger piece of the pie, right? But because there's fewer of us, if I take the number of the quantity the firm is producing times the number of firms, we actually end up with a lower market quantity. Okay? Now, firms will exit until that marginal revenue is equal to the marginal cost, exactly at the point where price is also equal to what? Average total cost, because in the long run, we know profits are going to be equal to 0, right? So if I'm thinking about this question, in the long run, what point will each firm be operating at? The minimum point of the average total cost curve. So that looks like here, I know it's a little bit small, but it looks like it's at a quantity of 300. Now, what is the value of average variable cost? So you wouldn't go down to the average variable cost curve, because if this is in the long run, where would my average variable cost curve be? It's the exact same as my average total. So at that quantity of 300, what is my average variable cost in the long run? It's the same as my average total at that minimum point would also be 300. Okay. If I instead asked you about the short run, right? Well, there we would need more information. I don't know what quantity they're going to end up at because I would need to know what the equilibrium price is, right? In the long run, in order for profits to be zero, price would have to be equal to marginal cost at the point that's equal to average total cost. We know from Module 9, if marginal costs are below average total, my new average is getting lower. If marginal cost is above average, average is going up, so this will always hit it at its minimum point. That's the point we'll always end up in the long run for a perfectly competitive market. Yep. In the short run, we don't know. Could be anywhere. Profits can be positive, profits can be negative. The only reason why we know we end up there in the long run is because in the long run, we know firms will enter and exit until profits are zero. Right? The only price that would result in zero profits here would be where price hits marginal cost exactly equal to average total cost. Right? Any other questions on this one? Okay. So the one we just went through. So let's see. I guess I would probably be a little bit more careful in my language here. I mean, in 11, we're talking about a monopolist. You can kind of see the flow of the exam. Once I start with perfectly competitive, we kind of change over to thinking about monopolists. So I'd probably add in, just to be very clear, you know, something like this, right? But because this is like, I didn't like mix problems around, I'm not going to do that on the exam, right? It kind of flows the way we covered things. Once we started talking about monopolists, I kind of had assumed that you would be thinking about monopolists in these practice exams. But yes, I'd have to kind of identify if I'm asking you about, and I just added that in because you could do the same thing for a monopolist or a perfectly competitive firm given that demand equation. Well, here and then here. So if we have a natural monopoly, so we have one depicted above, right? If I'm trying to minimize deadweight loss, what's the lowest price I can kind of set this at? So what's the price the monopolist is going to set here? So to find the price, I first need to know where is the profit maximizing quantity. That is where marginal cost is equal to marginal revenue. I then go up to the demand curve. So I would be setting the price at 60. So for the monopolist here, price is above average total, so my profits would be positive, right? Now, where would the perfectly competitive firm, what quantity would they actually choose? So let's be careful here. This is where we think about, in a perfectly competitive market, we know we end up at the minimum point of average total cost. When we're comparing these markets, we're saying, where would a perfectly competitive market or firm choose if they faced this downward sloping demand curve? We know they don't in practice, but if they did, where would they choose that quantity to be? Simply where supply is equal to demand. What represents supply? Marginal cost. So the perfectly competitive firm would choose this quantity of 30 and a price of 40. Now, what's the problem? If we try to lower the price down to 40, which would be what a perfectly competitive firm would do. The price of 40, is that going to be above or below my average total cost? So profits would be, in the long run, if this is only one firm, they would exit. What do we lose? The entire market. Deadweight loss is maximized if we did that, right? We'd lose everything. So how far can we push that price down? We know we don't want the monopolist to have positive profits, so we want to lower the price. They will choose to stay in the market as long as their profits are greater than or equal to zero, right? So what's the lowest possible price I could set where profits would be equal to zero? Well, if I start lowering the price, it's still above average total cost. Right where that price would hit average total cost, right, where it hits the demand curve, that would be where profits are equal to zero. If I try to lower the price anymore, what would be true about the price relative to average total cost? It's below, and I drive the firm out of the market. So I would love to set the price at 40, But if I do that, I'm not minimizing deadweight loss. I'm actually maximizing it because I forced that firm out of the industry. So I can only lower the price to that point where profits are equal to zero or where that demand curve hits my average total cost curve. So in this example, that would be at a price of what? 50. Right? So the lowest possible price we could kind of set there would be 50. Now I could also ask you, maybe just to kind of, if I didn't ask you about price, if they are regulating this market to minimize deadweight loss, what would the corresponding quantity be? Well, there, I can only regulate it down to where profits are equal to zero. That's at that price of 50. And then I would just need to go one step further, which is at that price of 50, what's the corresponding quantity? 25. Right? So I could use a price ceiling resulting in zero profits. What could I also use if I instead wanted to set the quantity? If I want to set the quantity at 25, I could impose kind of a quota. Now, a quota won't quite work here because what does the monopolist actually want to do? Produce less than 25 units. A quota says you can't produce anything kind of above it. Well, okay, we have a problem, right? We would have to actually force the firm to produce up to that 25th unit. But if I was simply asking you for what quantity would kind of result in that minimization of deadweight loss, it's going to be that point where profits are equal to zero. Right? I'd probably focus a little bit more on that price regulation. That's what all the kind of questions look at. But just to try to kind of tie in these concepts of anytime we're looking at a price, we can always find the corresponding quantity. Okay. Any other questions? I think I saw you, and then we'll kind of come over here and then there.
So I don't have the second practice exam, but I'm just confused to talk about excess capacity. Why we do the difference from the minimum of ACC from where this big competitive one.
So yeah, so 25 here. I kind of told you I might be a little bit friendlier on the final. And so this practice exam is probably going to be a little bit more like what I give you on the final exam. Might look a lot like it, right? So if I'm thinking here on 25, if I wanted to calculate quantity and price, I think your question is more of 26, where we're thinking about excess capacity. You're okay. So what quantity would the monopolistically competitive firm choose? Where marginal revenue is equal to marginal cost. So that's at a quantity of 20. They would then go up to the demand curve to set the price. Price is above average total. We would have positive profits. So I've got that quantity, right? In this example, where would the perfectly competitive market choose? So even if they didn't happen to be at the same point, which is other examples we looked at, we said we're going to make this decision as though where would the perfectly competitive market end up in the long run? That's what we're comparing to with excess capacity, because what excess capacity refers to is how far away are we from the quantity that minimizes our per unit costs. What are our per unit costs? Average total costs. So we know that the point where they're at their lowest is that minimum point, which is where the perfectly competitive market ends up. All right? So here, that's going to happen to be at the same point where the supply, marginal cost, and demand curve hit. So here I don't want to cause any confusion, right? There isn't a difference between those two, right? Supply is equal to demand exactly at that minimum point of the marginal cost, minimum point of our average total cost curve. This is where the perfectly competitive market would end up at a quantity of 26. So all I'm doing when I'm looking at excess capacity is I'm comparing what quantity would result in having the lowest per unit costs, or that minimum point of my average total cost curve, and where the monopolistically competitive firm is choosing. So when we were looking at that difference would be between what? 26 and 20, our excess capacity is 6. We would want to increase our output by 6 units to get to that lowest possible per unit cost. Okay? So that would be our excess capacity, but since we're talking about, just to kind of complete this, what would my markup be? Markup is simply the difference between price, how much I'm making on each unit, and the difference between the marginal cost of that last unit I produced. So here, the price they were setting was 80. The marginal cost at that quantity was 40. So my markup would be 40, just the difference between the two. So this is an example, and much more likely to be kind of the example I would give you on the exam. how would I calculate deadweight loss that exists because this is a monopolistically competitive market? Well, anytime we're thinking about deadweight loss, we're comparing to where total surplus is maximized, which is when we have a perfectly competitive market. So the perfectly competitive market, when we're thinking about total surplus is simply the difference between the marginal benefits and the marginal costs of the market. What represents the marginal benefits and marginal costs of the market? Supply and demand, right? So when I'm thinking about this perfectly competitive market, it would be everything below the demand curve, but above our marginal cost curve, I could calculate this whole area. Now, on the exam, if I had asked you to calculate total surplus here, well, we've got some like non-linearities. If we look at the bottom part of that, I wouldn't do that to you, right? I'll give you kind of a constant marginal cost. But it doesn't impact this problem because the portion we're looking at, we do have this kind of linear marginal cost, right? For every unit between where the monopolistically competitive market chooses and that perfectly competitive market, every unit there, we're missing out on the difference between our supply and demand curve, which what represents supply? The firm's marginal costs. So we'd simply be looking for the difference between the supply and demand curve for all of those 6 units. So what would the height of that triangle actually be? My markup. What does the base of that triangle end up being? My excess capacity. So in some of the other, I think the first practice exam and some of the problems we worked through in module 13, those don't have to be the same thing because we can have kind of that point where demand is hitting marginal cost and not be at the minimum point of the average total cost curve. I'll simplify to not cause any confusion, to make it a little bit easier for you guys. I would give you a depiction that looks like this, where those end up being the same point. So there, when we're calculating deadweight loss, really what are we looking at? The markup times excess capacity. It's a triangle though, so multiply that by 1/2, okay? So that's going to be what? 40 times 6 times 1/2 is what? 120, if I'm doing math in my head correct here, okay? Any other questions on that one? And then I had a hand somewhere over here, and then here, and then here.
Yeah, so number 8. So I'm just curious, so if I chose, so why would it be A as opposed to C if it's already going to shut down as the price is below?
So if I'm looking at this graph, and here where I've bolded some answers, it says it's in the short run. Why do I know it's in the short run, even if I didn't tell you? Average total and average variable costs aren't the same. So if the price was 30, if we're going back now to a perfectly competitive market, what is the perfectly competitive firm's marginal revenue curve? Simply the equilibrium price, right? I can't get away with charging anything different from that. Otherwise, I'll sell 0 units. So here I've got a price of 30. Where is that going to hit my marginal cost curve? At a quantity of 16. What's true about price relative to average variable cost? So if price is below average variable cost, what should this firm do even in the short run? So if I shut down, how much am I producing? 0. Now, what are my profits in the short run if I shut down? Well, this goes back to where we could look at word problems. If I shut down, my profits are negative whatever my fixed costs are, right? So in the short run, if I choose to produce nothing and I shut down, what are my profits? They're not 0. I still have to pay my fixed costs, right? So that's why they're negative. And in fact, if we had one of those word problems, we said another way of finding fixed cost is to take the average times the quantity I'm producing. Usually we don't have that information, so we said take the quantity I'm producing. How do I find average fixed cost? It's the difference between average total and average variable. So if I gave you values here, right, you could actually calculate what those are. Now, I didn't ask you to do this in this problem, and I probably wouldn't give you as like a continuous grid line like this, just in case I've kind of have these curves drawn not quite incorrect. But what should be true, if I look at the difference between my average total and my average variable costs, it doesn't matter what quantity I use. If I take that quantity and the difference at that quantity between average total and average variable, it should always give me the same average fixed value. So I could look at 20 times the difference between 70 and 40. that should give me the same fixed cost as if I look at, I don't know, 28, and then there's what, 50 and 60. Now, these aren't like perfect, like I'm kind of rounding a little bit because these aren't exactly hitting it at those points. So it'd probably be more likely if I asked you to do it that way. I'm probably, like we worked in class on Tuesday, giving you kind of a word problem example, right? Where I'm giving you very specific values for what that average total and average variable costs are. Or we had another one where, I think it was up here, right? So here, this is an example where if price was 20, that's definitely going to be below my average variable cost, so I shut down. Now, here's where it could get a little bit tricky if I gave you a depiction like this, because you might initially think, okay, I'm going to use that equation for when they shut down. Take quantity times it, the difference between average total and average variable costs. But if I look at the profit maximizing quantity, here, this is 20. Well, do I know average variable costs? Not quite, right? I know they're slightly above 25, so maybe I try to guess, but you shouldn't have to guess in the final, right? There should be something you can exactly tell. I didn't give you the grid lines here. So I don't know average variable cost at this quantity of 20. I can use any quantity to calculate that fixed cost value, which are my profits if I shut down, or just negative fixed costs. So I go out to this quantity of 30. At that quantity of 30, there I do know the value of my average variable costs, right? They're 30, and I know the value of my average total costs. So any quantity where I can find both my average total and average variable, I can use that quantity to calculate what my fixed costs are if I should be choosing to shut down. Now, if I shouldn't shut down, well, then I should go back to my profit equation. If I don't shut down, so in that other example, what did we have? So I think the price I was telling you was 30. Let's assume we had a price of 50, right? So let's say I change this to, even in the short run, what if the price was 50? If the price is 50, my constant marginal revenue would hit marginal cost right here. Is that above or below my average variable costs? Above. So how would I calculate profits then? Well, price is above average variable costs. So in this case, we had price was below. If price is above average variable, in order to minimize my losses, right, as long as price is still below average total, my profits will be negative. I should stay open, and there my profits become just our standard profit equation, the quantity I'm producing times the difference between price and average total cost. Now, if price is below average variable, right, or sorry, above average variable, but still below average total, why is there not a negative sign out here? Well, if price is below average total, what would this difference always be? And so there I end up calculating profits. I'd find that if price is below average total, I'll find that their profits are in fact negative. Okay. All right, I know I added some things into the original question there, but any other kind of questions related to this problem? Okay, and then we had you next. Yeah, so we looked at a very similar problem on the other practice exam, right? What is the current price that the monopolist would be setting? Well, they choose where marginal cost is equal to marginal revenue. They go up to the demand curve. Whoops, yeah. So price of 60, above average total, profits are positive. Where do we want this market to be if it was a perfectly competitive market? It would be where market demand is equal to supply or our marginal cost. So it'd be all the way out here. It's not quite, somewhere between 32 and 34. But if I try to lower the price to 20, what's going to be true there? Now I can start to see like average total cost starts to kind of increase here. So my price is going to be below average total. If I lower the price down to 20, what happens? Profits are, if this is a monopolist, they would exit. Does the market exist anymore? No. All of this will become deadweight loss. I've maximized my deadweight loss, right? So what's the lowest possible price I can regulate this market to? Wherever profits would be equal to 0, right? So where would profits be equal to 0? Well, if I start to lower the price from that price they were choosing, which was 60, at 50, profits are still positive. At 40, profits are still positive. At 30, well, now price is equal to average total cost, so my profits are 0. That's as low as we can possibly get the price to make sure that they don't leave. We would say they're indifferent there. So I'm asking you to find the lowest possible point where they would be indifferent. In practice, and I wouldn't ask you like this on the exam, but just kind of to, connect this to the real world. If I'm not sure if they'll stay or exit because they're indifferent, what might I want to do? Not set it down there at 30. I might want to set it like 30.001, right? 30.01, right? But the lowest possible price we could push them to where they're indifferent about leaving would be where profits are equal to 0, which is at that price of 30. Yep. Does that answer your question? Yeah, so if they're the only one in the market, right? We're thinking about these are their average total cost curve. In the long run, if price is below average total cost, we would exit the market, right? We shut down in the long run indefinitely. If I gave you average variable cost curves here, potentially they might remain open in the short run. But over the long run, what happens to that average variable cost curve? It goes up to the average total. And so in the long run, we know they choose to exit anyways. So yeah, technically, if we wanted to get like a little bit more in depth, maybe in the short run, I could regulate this market and keep the price low. But over time, once these firms realize, even if I could change my fixed factors of production, given this current regulation, I won't be earning positive profits. I'm going to leave. I'm not going to wait 40 years to do that and just hemorrhage money. I'm going to leave right now. Right? It almost becomes like a game theory model, right? Because they know if I choose to do this today, the regulation is still the same tomorrow. I'm still going to have negative profits. What's optimal for me to do? Just leave today as opposed to leave tomorrow. Yep. Yeah. Final be curve. I don't plan on it. I mean, do you want me to? I mean, I could reprint them and make it harder if you want me to add a curve on there. No, I mean, usually grades are kind of about where I want to see them on the final. Grades currently in the class are about where they typically are, so I don't expect there to be a curve. Yeah. All right, so we're looking at this one earlier. We're still looking at now not the short run, but the long run, right? So the current short run price is 70. So if I was looking at a short run price of 70, if it's a perfectly competitive market, marginal revenue would just be that price. So it hits marginal cost at a quantity where price is above average total. So if price is above average total, what is true about profits? They are positive, right? So in this short run, the profit maximize, or sorry, in the long run, what's going to happen to those profits? So even if short run profits are positive, if this is a perfectly competitive market, what will happen? Firms will enter the market, supply in the market will increase, which does what to the price? Lowers it until profits are equal to 0. So if you have a question where it asks you about long run profits, if this is a monopolistically competitive or a perfectly competitive market, long run profits are always equal to 0, right? So here we know that in the long run, bolded it, profits are 0. If I change this to short run, well, there we said profits were positive, right? Also, in the long run, what will the value of average variable costs be? Well, you might look at this and initially think, okay, if profits were 0, what will end up being true in the long run? Where will profits be equal to 0? When we're at the minimum point of our average total cost curve. So I might look here and say, okay, in the long run, each firm is now going to produce 28 units. Average variable costs look like they're about 50. Why is that not true, though, if I'm looking at the long run? In the long run, what happens to the difference between my average total and average variable? They're the same thing. My average variable, I start to eliminate my fixed costs, everything I can change, or I can move to a larger building, facility, etc. So my average variable cost curve increases until it's exactly the same as my average total cost. So when I'm looking at that minimum point of my average total cost curve, that will be my average total and average variable cost in the long run. So in the long run, where profits are zero, the minimum point of the average total cost curve. In the long run, though, it'll also be the minimum point of my, what's the same in the long run? My average total and my average variable. So if I end up at the minimum point of my average total cost, in the long run, I'm also ending up at the minimum point of my average variable cost curve, right? So I know the value of average variable cost in the long run would actually be 60 here. Now, this is a little bit small, but, right? 60, okay? And another question that wasn't asked here, but in the long run, what would the quantity that each firm produces be? Well, if I can identify what the long run price is, the minimum point of the average total cost, I can also identify what that, long run quantity would be as well, which is 28, right? So I could ask you about price, quantity, average values of average total, or values of average variable cost in the long run. Okay. Is that okay? Yeah. Yeah. So these show up again. So I said pattern recognition goes a long way. What do you likely think you're going to have questions on the exam? These duopoly models where I give you a table. Now, let's just say I didn't give you total revenue. I might do that. How could I reproduce this total revenue column? Total revenue is simply what? Price times quantity. So if you multiply price by quantity here, you should get these exact same values. Okay? I might not give you this on the exam. You might have to calculate total revenue. I might just give you the demand curve or the combinations of price and quantity. You can find total revenue by price times quantity. Now, if I'm looking at either a monopolist or a perfectly competitive firm, they need to choose the optimal quantity where what is equal to what? Marginal revenue is equal to marginal cost. I'm giving you a constant marginal cost here of 3. Okay? So what do I need to do? I need to go through and calculate my marginal revenue, right? Marginal revenue is what? The change in total revenue. Marginal means the change, so change in total revenue from the fact that I'm producing more units, or the change in total revenue divided by a change in quantity. So here, how much is total revenue going up by when I go from 0 to 5 units? Goes up by 45, right? Divide that by the change in quantity of 5, and I get 9. When I go from 5 to 10, how much is total revenue changing by? 35. Dividing it by that change in quantity, I get 7. Now, I could go through and calculate this for every single value, but what is going to be true? I'm giving you these linear demand curves. So we said every time quantity goes up by 5, price goes down by 1. So every time quantity goes up by 5, how much will marginal revenue fall by? It is twice as steep. So instead of going down by 1, it goes down by 2, which I can go through and calculate this and prove this to myself. But this will be my marginal revenue values. Okay? Any questions on that before we keep moving? Okay with this? Oh, do I have a value wrong here? Probably. So, sorry. I did change this to make it a little bit more difficult. So if I have here, what? So 70 plus 25 is 95. Am I looking at this wrong? I might have changed these to make this problem different. So let me think. What did I do here? 80, 75, 120. Am I doing bad math in my head? This would be what? 15 divided by, whoop, 5 is equal to 3. This one's going to be what? 25. Oh, sorry. So I changed the numbers as an example. I was setting this up as though I didn't give you total revenue. So if I gave you total revenue, you would always have kind of this twice as steep marginal revenue curve. I changed the values here to kind of make sure that you actually know the concept of we're looking for where the actual question is going to be where marginal cost is equal to marginal revenue. So thank you for asking. I changed these values a little bit from what they would be. So here, I guess if we go through and calculate this, this is what? 3. This is going to be 25 over 5. So 5. Here we've got 1, -1. So it shouldn't ultimately change our answer. But yeah, now this looks like it matches up, right? Yeah. Yep. Okay. So we've got our marginal revenue values, right? Where will marginal revenue be equal to our marginal cost? Okay. So for this first 5 units, is my marginal revenue equal to my marginal cost? No, marginal revenue is above. So do I want to produce those? Yes. Additional revenue is greater than the additional cost. What about these next 5 units? Yes. What about these next 5? Well, they're exactly equal. What about these kind of these next 5? Well, they're my marginal cost. Oh, sorry. You asked about question 16, didn't you? I'm working through question 15. So I'm doing this for a monopolist with a twice as steep marginal revenue curve. So there I gave you a constant marginal cost of 5. So we go up to the point where marginal cost is equal to marginal revenue, which is at this quantity of 20. What's true about marginal revenue? It is positive. So I know as long as marginal revenue is positive, my demand is what? Elastic. In 16, I gave you a different marginal cost value, but I said assume that they're, instead of breaking the agreement, that they're perfectly price discriminating. So a single price monopolist faces this twice as steep marginal revenue curve. If I can perfectly price discriminate, just like in the examples where we had duopolies, what ends up becoming our demand curve if I could perfectly price discriminate? Or what ends up becoming my marginal revenue curve? I just told you. What ends up happening? What is my marginal revenue curve if I can perfectly price discriminate? My demand curve. So there, for a perfectly price discriminating monopolist, they're going to figure out where that marginal cost of 3 is equal to the price, right? The point that I'm at on the demand curve, right? That's just the combination of price and quantity. That's my demand curve. So when marginal cost is 3, that hits my demand curve at a quantity of 35, right? Now, so I've got my quantity of 35. Let's say I gave you this instead, because technically, if you found that, you know C has to be the right answer. So on the exam, let's say I give you this option. Okay, so now I know it's either C or D. So at that perfectly price discriminating monopolist optimal quantity, what is true if they were kind of facing this twice as steep marginal revenue curve? Marginal revenue is actually negative, which if this twice as steep marginal revenue curve is negative, I know that demand is inelastic, right? So if I ask you for a perfectly competitive or a perfectly price discriminating monopolist, we know they're going to set the same quantity. We had an example like that earlier. So where does that constant marginal cost not hit this twice as steep marginal revenue curve? Where is it hitting our demand curve? So if we wanted kind of a visualization of this, what this is going to look like, and this is where you kind of keep these, like if you had both these questions, we said, here's our demand curve, here's this constant marginal cost, here's our twice as steep marginal revenue curve, right? If they're a single price monopolist, we know that the quantity is going to be set down here, right? So if I have any positive marginal costs for a single price monopolist, what has to be true about the value of marginal revenue? If I have any marginal costs, it's going to hit marginal revenue at a value where marginal revenue is positive, right? It has to be above. As long as I have marginal costs that exist, marginal cost is hitting marginal revenue at a value that is positive. So the single price monopolist will always choose a quantity that is on the elastic portion of your demand curve. Now, this isn't necessarily the case for a perfectly price discriminating monopolist or a perfectly competitive firm, right? So where would the perfectly price discriminating monopolist choose? Well, they don't have this twice as steep marginal revenue curve. Their marginal revenue curve becomes the demand curve. So they're going to set this quantity out here, which in this example, kind of lining up with our numbers, that happens to be where marginal revenue is negative. So that perfectly price discriminating monopolist can end up on the inelastic portion of the demand curve. Okay. Does that answer who I forget who answered or asked the original question? And I started solving 15. Sorry. 16 was not asking about a single price monopolist. It was asking for this perfectly price discriminating monopolist. But even in question 16, in order to be able to answer whether or not demand was inelastic or elastic, we base it off of that twice as steep marginal revenue curve, or we would need to calculate the marginal revenue based off of those total revenues given to us. So once we identified that optimal quantity for the perfectly price discriminating monopolist, what is true about marginal revenue if they were setting a single price? It's negative. That tells us demand is inelastic. Okay. So I get that that's kind of counterintuitive, because even though the price discriminating monopolist doesn't use that twice as steep marginal revenue curve, what tells us the elasticity of demand is that twice as steep marginal revenue curve. So even though they're not using it to make their quantity decision, what tells us whether or not demand is elastic or inelastic is the marginal revenue value that is based off of if we were setting a single price. Okay. So that one is a little bit tricky when we're looking at perfectly price discriminating monopolists, because you would find the quantity where their marginal revenue or their demand curve hits marginal cost. But to determine if it's elastic or inelastic, that is based off of the marginal revenue values if I was setting a single price. Okay. So that one's a little bit kind of trickier. When we're looking at a single price monopolist, everything's based off of that same marginal revenue curve. Okay. Does that, I forget who asked the question now. You? Does that answer? We got 15 minutes. Any other questions? Yeah. Say that again. I can't hear you. Price setting versus quantity setting. I mean, by setting the quantity, we're inherently setting the price. So there shouldn't really be a difference, right? I mean, in all these models, right, if I choose the quantity that maximizes profits, I always then go up to set the corresponding price. So they're really, I'm setting them both essentially simultaneously. By choosing a quantity, I am setting the price in the market. So there shouldn't be any difference. Do you have a question that you're referencing, or? Okay. Any other questions before, as we wait? We'll go here and then I'll go up there. So if I have a monopolistically competitive market, I think we did one similar to this last class, or we actually might have worked through this one. I get my sections mixed up. So if I'm in the long run, right, here's the monopolistic competitive market demand curve, twice as steep marginal revenue, upward sloping marginal cost. What should always be true in any example we look at for any firm? Marginal revenue should be equal to, so God forbid anybody gets this question wrong on the exam by answering D, right? This is, I mean, I've said this way too many times, right? Marginal revenue at the profit maximizing quantity in the short, in the long run for a monopolist, perfectly competitive firm, marginal revenue will always be equal to so we can rule D out right away, right? Now, here, we know that that's going to be true because that's where they set that quantity, right? If I have a monopolist or a monopolistically competitive firm, what should also always be true? Price should always be above marginal cost. We have markups in markets where there is any monopoly power. if that's a complete monopoly or even monopolistic competitive markets, we go up to the demand curve. So price should always be above our marginal costs. Okay? So that one should be true as well. Right? So this one we're really already done, but we can go through the other wrong answers. Right? Why do I know in the long run I can rule out A right away as well? If I had a perfectly competitive market in the long run or a monopolistically competitive market in the long run, what is true about my profits? Firms will enter and exit until profits are zero. What's the only way? As long as we're producing something, what's the only way our profits are equal to zero? If price is equal to average total costs. Okay? Now, if I have a monopolistically competitive market, we know they won't end up at the minimum point of our average total cost curve, right? So how do we end up on the minimum point of our average total cost curve? Only if the demand curve we face was completely horizontal. Who faces a completely horizontal demand curve? Perfectly competitive markets. So a perfectly competitive market, yes, ultimately that price would be equal to the minimum point of our average total cost curve. But if we have a monopolistically competitive market, when profits are equal to zero, are we at the minimum point of our average total cost curve? No, right? Price is still equal to average total cost, but we're not at that lowest possible point. So here, will price be equal to our minimum average total cost? Not for a monopolistic competitive firm. This would be true if we were instead looking at the long run for a perfectly competitive market. So C won't be true either. The only other one we have to go through, will price be above average total? Well, in the long run, if profits are equal to zero, if A was correct, what should this read as? What's the only way profits are zero? If price is equal to average total cost. So, well, there we go. So that one can't be true either. Right? So the only one that was true there was we know when we have any monopoly power, there will exist a markup or price will be above marginal cost. Okay. Now, another thing I could throw in there that's maybe a little bit trickier. What has to be true in these monopolistically competitive markets? Price is actually going to be above two other things. So if price is above marginal cost, but marginal cost is equal to marginal revenue, what is price also greater than? Marginal revenue, right? Those are the same values. So if it's above marginal cost, it's also above marginal revenue. I also know that price is going to be above what? If we don't end up at that minimum point of our average total cost curve in these monopolistic competitive markets, the price they set, remember, what did we have with a monopolistic competitive market? We had excess capacity. Why? Because we weren't operating at the lowest per unit costs. So we know the price they set will be at an average total cost value that is actually not the lowest possible per unit costs, right? We have some excess capacity, and so the price they set will always be above that minimum point of our average total cost curve when we look at monopolistically competitive markets. Okay. Did that answer your question? Now I forget where exactly it was at. Any other questions on this one? Did you find your question or no? Okay. All right. And the next person I had was back there. This one? Yeah. So I'm a little bit somewhat worried because we haven't had a lot of time or we haven't worked through, people haven't asked questions on these. So you're definitely going to get normal form game models, and you're definitely going to get these extensive form game models where decisions are made sequentially. Okay. So I'm just going to draw this out to show you what I think is an easy way of solving these that you can do on the exam. So here I've got the exact same values. Hopefully I've copied everything down correct here. We can go through this kind of quick, right? So with these sequential game models, person one makes the decision, and then person two goes next, right? So I think here we were setting quantities of 30, 40. Yeah, here we go. So the way we solve these is we start out with the person who goes second and then work our way backwards. So this is how you would solve these very easily. I'm going to look at each branch of the tree. If firm 1 chooses to produce 40 units, firm 2's payoffs, I'm not going to try to trick you here. I'm always writing them in order. So firm 2, their payoffs are always on the right. Firm 1's payoffs are always on the left. So if firm 1 chooses to produce 40 units, what should firm 2 do? If these represent profits, right, and generally in all these examples, a higher number is going to be better. So higher profits, what should I choose to do? Well, 300 is greater than 250, so I choose to produce a lower number of units. So right away, I know firm 2 is never going to choose to go down this branch. So I'm going to cross that out, right? If firm 1 chose instead to produce 30 units and we were on this branch, what will firm 2 do? Well, 400 is greater than 350, so they'll produce 40. We know they won't choose this option. Okay? So we've ultimately decided what firm 2's best response is to both of firm 1's possible choices. Knowing this ahead of time, like knowing what the payoffs would be, firm 1 says, well, look, if I choose to produce 40 units, I know what firm 2 will always choose to do because they're going to act out of self-interest. So if I produce 40 units, what are my payoffs going to be? 400. If I choose to produce 30 units, what do I know my payoffs are always going to be? Well, I know firm 2 there would always choose to produce 40 units. I know my payoff will be 300. Which of those is better? So firm 1, knowing that this is going to be the decision of firm 2, would always choose to produce 40 units. This is our Nash equilibrium. Okay? So I would go through any extensive form game. You'll definitely see one on the exam, if not multiple, right? And I would solve them out for what the Nash equilibrium is in this exact same way. Now, just like normal form games, I could ask you a follow-up question. Could. I've written the exam and it's printed. So, if this was the Nash equilibrium, do I have an example of a prisoner's dilemma? What is the definition of a prisoner's dilemma? Whatever equilibrium we end up at, there's another outcome that could result in higher payoffs to both people. So here, if we were over here, would both people be better off? No, they'd actually be worse off. What about if we were over here? Well, one person would be better off, but the other person wouldn't be. So that doesn't classify. What if we were over here? One person would be better or worse off, one would be better. So no, we would not have an example of a prisoner's dilemma here. Now, let's just for the sake, and I don't think the equilibrium would end up being the same, but just to give you an example, let's say the payoffs over here were 500 each. Now, would we have an example of a prisoner's dilemma if this still was the Nash equilibrium? Yes, because there would be another outcome where both people were better off. Okay? Now, once again, if you go through and solve this, this might not end up being the Nash equilibrium. I'm just giving you these values to kind of think about what would look like a prisoner's dilemma if there was another outcome where both payoffs were higher for each individual. Okay? Any questions on this? Okay. Yeah. For the extensive form games? Yeah, for the normal form games and extensive form games, I'll give you kind of either the 2x2 matrix or I'll give you what that decision tree looks like. Yep. Now, I would also point out, because this doesn't maybe show up as much, I think, in the first practice exam, and I can't remember exactly all the answers in the second one. But when we're looking at these normal form games, or we're looking at these extensive form games, we want to remember there are always possible, these are all the possible options. We can have one equilibrium, like we just had, but we can end up with multiple equilibrium as well. So you can have an example where you find there are actually two Nash equilibrium. That doesn't mean you solved it wrong. That's a possibility, right? If I also can have that there are no equilibrium, right? So that won't be true if I look at these extensive form games. For these extensive form games, we actually will always have an equilibrium. But for our normal form games like this, we can end up with scenarios or examples where there is no Nash equilibrium. That's a possible answer as well, okay? So just because you find no equilibrium or multiple, that doesn't mean you did it wrong. Those are possibilities, okay? Excuse me. So as we're kind of ending here, are there any other last minute kind of logistical questions not related to content? Okay. All right. Before I kind of let you guys get out of here, please keep an eye on Canvas. I don't expect there to be anything that changes from now to the final, but I won't meet with you again until the final exam, right? So if you have any questions, please send them to me sooner rather than later. If you send them Monday night or Tuesday during the day, Tuesday I've got other exams and I'm going to be pretty busy. So I might not be able to kind of get you a response before the exam if you send it to me, say, Tuesday late morning, okay? So we really want to end the semester like this, guys. All right. Okay. So I just wanted to say I appreciate you guys. It was a great semester. I'm hoping it ends up well for everybody. If you do have content questions, you can email them to me. I will try to respond as quickly as possible and might even be able to provide you kind of written solutions, right? If it's only, a question or so, I will keep an eye on my email and respond as quick as possible. If you have any concerns, please reach out sooner rather than later. I wish you guys all the best of luck, and I will see you on Tuesday at 5:20, okay?